In this video, we are going to look at a paper by Damodaran, which is also one of the required readings in the CFA Level 2 syllabus for quantitative methods. Now, the title of this paper is Probabilistic Approaches, Scenario Analysis, Decision Trees, and Simulations. So I would only like to highlight one part of it, which is on how simulation is done based on the example highlighted in this paper. Now, I'd like to just jump over to the PDF version, okay, and because it's easier for me to highlight. So I'll just jump to page 27, right? So in this case, Damodaran actually used an example of a simulation where we have Home Depot, okay, that wants to open a new store that is similar to their traditional format with very similar sizes. And this new store that they're going to open is going to last for 10 years. Okay, so that's the operating horizon. And at the end of the 10 years, the store will be closed down and there will be no salvage value. So in this case, when we want to value that new store, we will need to have, of course, we can use historical data from the other stores to know or to forecast the future revenue of these stores for the next 10 years. Okay, we can, of course, base the operating margin, okay, on the previous stores since the business model is about similar. Now, of course, what then is shown in the paper, okay, is the historical data, okay, which is shown in the form of a distribution. So like here we have a revenue per store for all their US stores in 2005. So this is a distribution of stores. And then we also have the distribution of pre-tax operating margins, which we see is most of them is between 6 to 12%. Okay, and some is less than 6% and some is greater than 12, from 12 to 14%. All right, so the assumptions made here, okay, is summarized on page 30. Okay, so we'll just jump to this portion here. So of course, in order to value, okay, Home Depot store cash flows and of course the value, the base revenue, okay, the assumption is the base revenue will have an expected value of $44 million and the standard deviation is $10 million. Okay, and it follows, the revenue is assumed to follow a normal distribution. Now for pre-tax operating margin, okay, it is assumed to be uniformly distributed with a minimum value of 6% and a maximum value of 12% with an expected value of 9%. So for a uniform distribution, the expected value is just the average of the minimum and the maximum, which is 6 plus 12 divided by 2. And we'll assume that non-operating expenses, okay, will be $1.5 million per year, right? So this is the assumption that we'll be using. And for revenue growth, okay, we will assume that the revenue growth is approximated by the average real GDP growth, which is 3%, and then added to expected inflation rate of 2%. So 3 plus 2, that will be 5% in terms of the growth rate. Now, the cash flow is expected to be generated for 10 years, and there is no expected salvage value from the store closure. We'll use a cost of capital of 10%. Okay, and the tax rate will be 40%. Of course, using these inputs, then we can calculate the expected value of the store. So what is shown in this paper here is that we will then start from the base revenue, okay, which is 44 million. Okay, and then they will calculate the after-tax cash flow. And from there, they will input it into the formula. The formula here is based on the present value of a growing perpetuity, and that arrives at $11.3 million. And this is what is known as the risk-adjusted value, okay, because the figures have been adjusted for the risk, okay, which is in this case 10%. Then Damodaran did a simulation with 10,000 runs, okay, using Crystal Ball. Now, of course, a Crystal Ball is an add-in to Excel. It has a free trial, but for a very short period of time. But you have to pay to use it. Okay, and the graph from this distribution for the Monte Carlo simulation is shown on page 32. So you can see this is the output from the crystal ball. We can see the distribution of the store value, okay, where the minimum is, where the maximum is. Okay, and so what I'm going to do now is I'm going to show how this can be done in Excel, okay, without using the add-in. I'm going to replicate the simulation. Of course, we will not get the exact same result as what we see here, okay, but the steps and the process are the same, and you can do it on your own by just using a data table. Now, of course, if you want to run the simulation using you want to code it with VBA in Excel, you can do that, okay, but for this demonstration, I'm only just going to use a data table. Right, moving on to the Excel spreadsheet. So we are going to key in the inputs, okay, from the store. So of course we know that for the revenue, okay, so the base year revenue, let me type that in. So we have the base year revenue, and for which we have the expected value, which is the mean revenue, and then this is the standard deviation, right? And then we have the pre-tax operating margin, and of course there we have the minimum value and the maximum value, and then there is the expected value as well. And then we have the non-operating expenses, we have the tax rate, we have the cost of capital, and we have the growth rate, okay. And of course our horizon here is 10 years, okay. So this is in terms of years. Let me just call it years here. So I'll just create all the labels. These are the subcategories, so I'll just align them on the right to make it clearer. Okay, this on the right as well. So base revenue in millions for expected value is 44 million. And the standard deviation of revenue is 10 million. The pre-tax operating margin minimum is 6%. Okay, and the maximum is 12%. And the expected value is 9%. Non-operating expenses is assumed to be 1.5 million. Tax rate is 40%. Cost of capital is 10. Growth rate is 5%. And the horizon is 10 years. Okay. So let's first calculate the expected value of the store, okay, which is to replicate what is shown here, okay, to get this 11.53 million. So I'm not going to use the formula here because you can easily key in this to your calculator, but I'm just going to show you how this can be done on the spreadsheet. Right, so first we'll have to calculate the base year after tax cash flow. All right, so that will be equals to the base year expected revenue, 44 million, times the expected value of the pre-tax operating margin. So this gives us the pre-tax operating income. Then we minus, okay, we will minus non-operating expenses, 1.5 million, and then we multiply it by 1 minus the tax rate. Okay, so this will give us a base year after tax cash flow of 1.476 million. So just to verify that, this 1.476 million, okay, this is a base year after tax cash flow. Now, of course, to calculate the value of the store, I'm now going to plot out or calculate the after-tax cash flow every year up to year 10. So, of course, here we have 1, okay, and then you can have 2, okay, and then you just highlight this all the way to 10, okay, and then we have the after-tax cash flow. This is the after-tax cash flow, right? Then, starting from the base year, okay, base year, we'll just lock it in and then multiply by 1 plus the growth rate. Okay, let's lock that in as well, and to the power of the year. So every year the after-tax cash flow will grow at 5%. Okay, let's copy that down, make sure that everything is tied to these two. Okay, right, so we have everything we need. So lastly, we just have to calculate the value of the store. So the value of the store here will be NPV using the NPV function. The rate here is 10%. Okay, and then we select highlight all the value from year 1 onwards, and we get 11.53 million. Okay, so this is the expected value of the store. Okay, 11.53 million. Now, this value on its own is just a single number, and it really doesn't give us much information about the potential or the possible distribution of store values. Okay, without the distribution, we are not able to assess the risk of the distribution. Okay, we do not know what is the lowest value, what is the potential highest value. We don't know whether it's skewed to the right or skewed to the left. Okay, and we cannot assess things like what is the probability that the store value will be negative, or what is the probability that the store value could be more than 30 million. Okay, so we can't assess that kind of risk without doing a simulation. Okay, which is what we're going to do next. Right, now before we start, just take note that for the base year revenue, the assumption is that this is following a normal distribution. So let me just color that in. Okay, just to remind us that this is normal. And for pre-tax operating margin, this is based on a uniform distribution. All right. So using this, I'm going to now calculate. I'll leave this here. I won't change this, but I'll recalculate another set of columns the values of revenue based on the normal distribution and the pre-tax operating margin based on the uniform distribution. So in the Monte Carlo simulation, what they will do is for these variables which have a probability distribution, we will have to generate a random number. Okay, and based on the random number, we will then generate the revenue based on that random number and based on the distribution. And I'm going to generate another random number for the pre-tax operating margin to generate the expected value, okay, or the generated value for the pre-tax operating margin based on a uniform distribution.